The pre-ordered traversal of a binary search tree is given by 12, 8, 6, 2, 7, 9, 10, 16, 15, 19, 17, 20. The post-ordered traversal of the tree is, and we have been given 4 options here. So this is a question from data structures regarding binary search tree and the pre-ordered traversal, in-order traversal, post-order traversal, etc. So what is post-order traversal? If we have a binary tree like this, A, B, C, what the pre-order traversal would do is, it will print the node A first, and then it will traverse the left subtree, and then it will traverse the right subtree. So if the tree is only this much, it will print A first, and then B, and then C. So this is pre-order traversal. In-order traversal means if the node is like this, first it will traverse the left subtree, then it will print the current node, and then it will print the right subtree. So for this tree, in-order traversal will print B, A, C. And post-order traversal means it will traverse the left subtree first, then the right subtree. After that, it will print the current node. So for this tree, it will print B, C, A. So in the question, they have only given us the post-order, the pre-order traversal of the tree. And one more information is given, it is a binary search tree. So based on these two information, we need to find out the post-order traversal of the tree from the options given here. So we won't be doing the entire post-order traversal of the tree. We'll just look at the options and then we'll choose the best suited one. Okay, we don't need to find out the entire thing to answer this question. So we'll start. In pre-order traversal, the first node printed will be the root node. If it's a tree like this, it will print first the root node. After that, it will print the left subtree and then the right subtree. So clearly in this, 12 is the one that is being printed first. So clearly in our tree, 12 will be the root node. So I'll put 12 here, and then there will be a bunch of numbers to the left side and then a bunch of numbers to the right side. So if a tree is like this, 12 and then left and right, what will happen in the post-order traversal? In the post-order traversal, it will print the left subtree first, and then it will print the right subtree first, and then it will print the root node at the end. So 12 will be the last number printed in the post-order traversal. But if you look at the option, A is saying 20 is the last number printed. So clearly A is wrong. Only B, C and D are printing 12 at the last. So we can eliminate option A. We only need to look at option B, C and D now. Now we look at the second information given in the question. It is a binary search tree, meaning all numbers less than 12 should appear to the left side of 12 and all numbers greater than 12 should appear to the right side of 12. Now in the question, if you see 8, 6, 2, 7 and 9 and 10 are less than 12. 16, 15, 19, 17, 20 are greater than 12, right? Which means that 8, 6, 2, 7, 9 and 10 will appear to the left side of 12, and 16, 15, 19, 17, 20 should appear to the right side of 12. Meaning the left subtree of 12 will be made up of these numbers and the right subtree of 12 will be made up of these numbers. Now if you look, 8 is the second number printed. So what does that mean? The first number printed will be the root node 12, and then we will go to the left subtree. The second number printed will be the root node of the left subtree. So that is 8, meaning 8 is the root node of the left subtree. So to the left, the immediate node would be 8. Similarly, we have 8, 6, 2, 7, 9 and 12 in the left subtree, and we have 16, 15, 19, 17 and 20 in the right subtree. So we will be printing the whole left subtree, that is 8, 6, 2, 7, 9 and 10. We will be printing up to this. After that, we will go to the pre-order traversal of the right subtree. So in the right subtree, which will be the first node printed? The first node printed would be the root node of the right subtree. And the first number is 16, which means that 16 is the root node of the right subtree, which that we can clearly say that here. So the left subtree will look like something like 16. And then some left subtree and then some right tree. Okay. Now let us look at the post-order traversal of this tree. But how will it look? It will print the left subtree and then it will come to the right subtree. It will print this tree to the left of this, and then it will print this part to the right of this, and then it will print this node, and finally it will print this node. So the post-order traversal will have the last node as 12, which we did earlier, and the second last node would be 16. Now if you look at the options, only B and C has the second last node at 16. D has the second last node as 19. So option D also we can eliminate. Now we know that to the right side of 12 we will have 16, 15, 19, 17 and 20, and the first node is 16 here. So this is again a binary search tree, meaning numbers less than 16 will appear to the left side of 16 and the numbers greater than 16 will appear to the right side of 16. The rest of the numbers are 15, 19, 17 and 20, which meaning 15 will appear to the left side of 16 and 19, 17 and 20 will appear to the right side of 16. Now again let us do the post order traversal. What it will do is, it will print this tree, it will come here, it will print the left side of this, that will be 15, and then it will print the right side of this node, that will be one of these three numbers, and then it will print 16 and then it will print 12, meaning the last number printed in post order traversal will be 12, the second last number printed will be 16, and the third last number will be one number in the right subtree of 16. So right subtree of 16 has 19, 17 and 20, so one of these three numbers will be printed there. Now if you look at the options, option C is saying that 15 is the third last number printed. Now that will never happen. The third last number has to be one of these numbers, 19, 17 or 20. Now from the options only 19 is the correct one, that's given in option B. Option C is saying 15, so option C is wrong. Option B is saying 19, so option B is the right answer here. We don't need to look further, we have already eliminated three options which will never happen, and the only one left is B. So you can try constructing the tree in similar manner and then verify that this itself will be the full thing given, but during gate you don't need to do it for the entire thing. Only once you eliminate three options you can give that B is the right answer, B is the answer here.